Hi, grade 11s. Today we're going to look at some of your circle theorems that you dealt with this year. However, we're not going to do all of them. We're going to look at only two of them, and then the other two you'll look at them because those are the four theorems that you're expected to know in your exam or to know how to prove in exams. Of course, there are a lot of theorems that you need to know, but only four you're expected to know how to prove. Let's look at the first one. First one says, prove the theorem which states that the line drawn from the center of a circle perpendicular to a chord bisects the chord. So we need to know how to prove this theorem. So we've got to know how to prove that this line here, OC, which is perpendicular to line AB, bisects the chord. So we need to understand what you're required to prove. So we are required to prove that this length over here, which is AC, is equal to this length over here, which is BC. So we are required to prove, we can prove that AC is equal to BC. We can prove that, we are required to prove that. So to prove this, we need a construction. So to construct here, in this case, we can use grade 8 mathematics to prove that this equals that by formulating two triangles. This is how we construct a thing. So if I join OB and I also join OA, so I'll write that in my construction I joined OA and as well as OB. Now how do we prove this? We use congruency. To prove congruency, we must prove that this triangle is congruent to that one. If these two triangles are congruent, it will mean that this AC is equal to CB, which is that will be equal to that. Alright? Now, how to prove it? So we're using two triangles. You tell the examiner, say in two triangles, OAC and the other triangle, OBC. We need for congruency three things that are equal. First, OA is equal to, in this triangle there, equals OB in the other triangle. And the reason in geometry must always give a reason. It's because that's a radius. So those are radii. There are two radii. So they are radii. Next, you can see that OA of this triangle is equal to OC of this triangle, same as OC of the other triangle. So OC equals OC. So that will be a common side. Common side. Next, we can see that in this triangle is 90 degrees and in this one is 90 degrees. So angle OCA is the same as angle OCB. They're equal sides. They are both equal to 90 degrees. Both equals 90 degrees. Therefore, it means that the two triangles, triangle OAC is congruent to triangle OBC. Triangle OBC, and the reason for congruency, in this case, this we said it was equal to that, and that side equals to this side on this one, and that's 90. Therefore, the reason for congruency is 90 degrees hypotenuse and the side. To remember that from grade 9. Now, let's check whether these two things, AC is equal to BC. Check. AC are the last two letters here, and BC are the last two letters. So AC equals BC, AC equals BC. So therefore AC equals BC, and our reason is because the triangles are congruent. Alright? Now let's look at another theorem that you need to prove. This one now says, prove the theorem which states the angle at the center of a circle, that angle over there, meaning that one in this case, is twice the angle at the circumference. You've got to prove that that angle at the center is 2 times that angle. So you must prove that angle BOC, the angle is equal to 2 of that angle A there is 2 angle A over there. Let's put A there to make things simpler. So again, as we did in the previous one there, every time you go to prove a theorem, you must do some kind of construction. I use the red thing so that you can see. So my construction in this case, to prove that I draw a line here, going through from A to O, all right, up there, let's go through there, let's say to D there. Now I've got that line going over there. That's our construction. Our theorems, there must be a construction. Now let's label angles because I've got too many angles here. So let's look, they say this is 1, that is 2. They say this is angle 1, that is 2 here. So it's O1, that's O2, that's A1, that's A2. Right? So in our construction, we constructed AO to D. So we constructed AO to D there. Now, how do we prove it? Alright, now check here. We can see that angle A1 is equal to angle B. Can you write that? Angle A1 is equal to angle B. Why are they equal? Why is that angle equal to that one? It's because they are subtended by equal sides. Okay? They are just opposite equal sides. Next, now let's check here. What can you say about angle O1? We can see that angle O1 is equal to those two angles is equal to angle A1 plus angle B, and the reason the exterior angle of a triangle. Now, which means that angle O1 is equal to 2 of the angle A1, because we said previously that B and A1 are the same. So it's 2 angle A1. Right? Now, similarly, if I move to the other triangle, so if I say similarly here, if I move to this triangle here, we can see that angle O2 will now be equal to 2 of the angle A2. Right? It's the same procedure, so they're the same as 2 of those. And therefore now we can combine these two angles. What does that mean? It means that angle O1, which is this one, plus angle O2, which is this one. O1 is 2A1, is 2A1. So plus O2, O2, which is 2A2, is 2 angle A2. Now if I factorize this, check, I get O1 plus O2 is equal to 2 times A1 plus A2. Right? But what is O1 plus O2? The angle O1 and O2 is the same as angle BOC, so which implies that angle BOC is equal to 2 of angle A1 and A2. Now A1 and A2 is just angle A, is equal to 2 angle A. You can see that what we are required to prove that BOC is 2A is that one there. So you can try now the other two which you are also expected to know how to prove. So you will also get a chance to prove these two on your own from the past papers on your own, and also now prove on your own these other two triangles, some theorems. For instance, the other one says prove the theorem which states the opposite angles of a cyclic quadrilateral are supplementary. They want to prove that the opposite angles, because this is a cyclic quad, there are 4 corners, you must prove that these two angles are supplementary. What are you required to prove? Required to prove that if I add these two angles supplementary, add 180. You must prove that angle A, if you add angle C, you'll get 180 degrees. Or you'll have to prove that B, if you add with the D, angle B, plus angle D is equals to 180 degrees. That's what you're required to prove. So yours is to think about what construction you need and you try and prove that one. The other one is this one, which says prove the theorem which states that the angle between a tangent and a chord is equal to an angle in the alternate segment. You are required to prove something. The angle between the tangent and a chord. This is the angle here, which is between the tangent and the chord, that it is equal to an angle in the alternate segment. You must prove that that angle there is equal to that one there. If you don't want to prove that one, you must prove that one on this side over here, that it is equal to that one over there. Alright, so in this case here, I chose to prove that one there, so you are required to prove that angle DBA is equal to that angle there, which is E over there. If you don't want to, you can try and prove that one equals to that one, and you do the whole thing. Alright, those are the two theorems that you must prove on your own now, besides the ones that I gave you. But if you want to reinforce what we just did there, so you can go through your website www.thebrighterfuture.co.za, grade 8 to 11 papers. The grade 11, you do DBE papers, paper 2, November 2013 and 2015. There's question 11, 11.1, question 10, 10.1. Or the Eastern Cape paper 2, November 2015, question 9, the 9.1. Or you try the IB paper 2, November 2013, question 6A. Remember, I said that there are only 4 theorems that you are expected to know how to prove. It's the 2 that I've proven and the other 2 that you've got to try on your own. You don't know how the examiner will ask a question, which question will be asked in the question in your question paper, or which theorem will be expected to know how to prove. And later on you'll get riders where you'll have to prove or solve theorems using solving riders using those theorems. Okay, good luck grade 11s, and always try and work as a team so that you can discuss how to approach things before you can ask for assistance from teachers. But of course, if you've got any questions, we are always available for you to help with the work. Good luck grade 11s.